All right, well, this is a little bit different. Me teaching the class without me being there. So we're going to continue with what we did yesterday. And that is section 1.5, and this is going to be part 2. And this one's called the Properties of Inequalities. So what we're going to do is we're going to look at some inequalities. We're going to learn a little bit how to work with them. And we'll do a little bit more on Friday with this, but we're just going to kind of get into it a little bit today. So the first part, we're not really doing any math. We're just going to look at some things that are true about some inequalities. So let's look at this very first one. This first one is called the non-negative property. Non-negative property. Sounds kind of weird. So if it's non-negative, if it's not negative, what do you think it is? Well, if it's not negative, it's probably positive, but it could also be something else. Okay, what else do you think it could be? If it's not negative, could be positive, but it could also be zero, because zero is not negative and zero is not positive. So it could be anything positive and anything that's zero. So this is how they write it. In the book, they write a squared is greater than or equal to 0. So why is that non-negative? Because no matter what number you put in for a, if you square it, it's always going to be greater than 0, which means it's going to be positive. Okay, anytime you're going to see this quite a bit, things that are greater than 0 and greater than other things like this. But anytime it's greater than 0 means it's going to be positive, and it could be equal to 0. So if I put a 0 in for a, 0 squared is 0. That's the only time that this thing could actually equal 0. But I could put any number in, any negative number, any positive number. If I square it, it always turns positive. So that's basically what that means. All right, pretty simple. Let's look at one that we're going to use a little bit more than what we're going to use on that one. We will use that a little bit, but on this one, this is a really big one. So this is called the addition property of inequalities. Hope you're taking notes on this and you're not fooling around just because I'm not in class. I still want you paying attention, and I still want you taking notes. T-I-E-S. Put the dots on the I's. There we go. So this is the addition properties. I don't know why I put property. I guess there is two properties here. The addition properties of inequalities. So here's the first one. I'll tell you what. Let's change colors just to make it look a little nicer so it stands out a little bit. So this one starts off, it's an if-then sentence. I don't know if you remember in geometry, you had if-then statements. So if A is less than B, so okay, A is a smaller number than B, then watch what happens. I'm gonna do it like this. I'm gonna put like this. Now watch what happens. And let's put this in a little bit of a different color. Basically what this is saying is if you add something to the A and you add the same exact thing to the B, this is still going to be less than this. Okay, so if you start off with A is less than B, you start off with a number that's smaller than this number right there, and you add two things to it, this left side is still going to be less than this side over here. You can try that if you want to with any numbers. Let's just try, keep color coordination here. So I don't know, 3 is less than, what happened? Oh, there it goes. 3 is less than, I don't know what, 5, let's say. All right. And what are we going to do? We're going to add something to both sides. So add, let's make it super easy. Let's just add a 1 to both sides. Add a 1 here, add a 1 here. So 3 plus 1 is 4, obviously, is less than 5 plus 1, which is 6. So 4 is still less than 6. It doesn't matter. It doesn't matter if C is a negative number. It doesn't matter if it's a positive number. It doesn't matter if it's 0. Same thing with A and B. As long as A is less than B, if I add something to A and I add the same exact thing to B, excuse me, wow, then this left side is going to be less than the right side. Okay, you can try that yourself. You can put some other numbers in there if you wanted to. All right, now the next thing is very, very similar to it. I won't take the time to explain it. Let's make sure we're back into this color. So instead of if A is less than B, what do you think the next one's going to be? If A is greater than B, then it's kind of the same deal. I'm going to put an A here, put a B here, and then watch, let's do this. Let's go with the colors here. So watch this. If I add a C to the A and I add a C, which means it's the same number. It doesn't have to be the letter C. It could be any number at all. But as long as it's the same exact number on the left side and the right side, normally, remember equalities, whatever you do to the left, you do to the right. If it's an equal sign, this works with equalities as well, but it also works with inequalities. So let's go back to the orange. And then I could do this. So if A is greater than B, so if A is bigger than B, if I add something to both sides, A plus C, the left side, is still going to be greater or bigger than the B plus C. Just because you add something to it doesn't mean it's going to make this side less. All right? It doesn't matter if it's a negative number or a positive number. Let's just try it. I thought we were just going to fly through this, but let's just do this. Stick a number in here and see if it really works. So we did positive numbers up here. Let's do negative numbers, all right? So let's say negative 2 is greater than, give me a number that's bigger than negative 2. Well, I can't hear you. So let's try, let's go 5. Let's go positive number, okay? So, I'm sorry, negative 5. So negative 2 is greater than negative 5. All right, would you agree? Yeah, I think so. So what are we going to do? We're going to add something to it. So let's just add a positive number. We could do a negative number, but let's say a 3. All right, so let's add a 3 to this side. Let's add a 3 to this side. Now remember, negative 2 is bigger than negative 5. So let's see if adding a 3 to both sides changes that. Well, it won't, because negative 2 plus 3 is 1. Negative 5 plus 3 is negative 2. Look at this. 1, positive 1, is still bigger than negative 2. So it works. Basically, all this is saying is when you have an inequality, you can add something to both sides, or subtraction too. Subtraction does the same exact thing. All right, it's just adding the opposite. So I can add or subtract something, the same thing from both sides. It's not going to change the sign. It's not going to change whether this is negative or less than or positive. Or I keep saying positive. If it's less than or greater than. All right, so it doesn't make any difference. So if you have an inequality to begin with, if I add something to both sides, or if I even subtract something from both sides, it's not going to change the inequality. Right? Doesn't matter if it's less than, doesn't matter if it's greater than. Right? That's a really important thing to understand. Back when you did Algebra 1, you probably did this stuff, at least in Algebra 2, I know you did this stuff. You probably did it in Algebra 1. But the teacher probably didn't go through all this rigmarole. They probably just said, on an inequality, whatever you do to both sides, if you add or subtract to both sides, it's not going to change the sign. It's not going to change the inequality. But this is the reason, okay? We're getting real specific here, and we're given specific reasons that this would be true. So that's addition. Now, again, addition and subtraction are basically the same thing. Subtraction is just adding the opposite, adding a negative. It works. Try it. You could subtract things from both sides. You could subtract a C from both sides, and it's still going to work. All right? So now we've talked about addition, and we've talked about subtraction. Let's go to multiplication and division. So this is called the multiplication property of inequalities. Property of inequalities. All right. So now we're talking about multiplication. Again, the same thing works with division. We can throw in division in here as well. All right. They just say multiplication, but we could include division in here as well, because really division is just multiplying by a reciprocal. So division is kind of multiplication. So division is multiplying by reciprocal. So division and multiplication are kind of the same thing. All right. So let's write out some if-then statements. I'm not going to take quite as long to do this part as we did the addition of subtraction. If you wanted to throw some numbers here and see if they work, feel free to do that. All right. So if A is less than B, it's kind of how we started off before, and if C is greater than 0, which means what? If it's greater than 0, it must mean a positive number, okay? So if C is a positive 0, not a positive 0, if it's a positive number or it's greater than 0, then let's do this. We'll do this, and let's do the different color scheme again with this, all right? So watch what happens. Instead of adding a C to both sides or subtracting a C from both sides, what do you think we're going to do with multiplication? We are going to multiply both sides by C. And this works. If A is less than B, all right, and if C is positive, this is really, really important right there, okay? If C is positive and you multiply a positive number by both sides, AC is still going to be less than BC. You can throw some numbers just for the sake of time. I'm not going to throw regular numbers in there, but you can do that. Pick a number for A and B. Just make sure that A is smaller than B, all right? And then take any number. It could be a positive number. I'm sorry, it has to be a positive number. Take a positive number because C has to be greater than 0. Multiply both sides by C, and you're going to find out that this number will always be less than this number, all right? So not much has changed except for this next step. This next step is pretty important. So watch this. If A is less than B again, all right, so we start off with the same thing, but we are going to change something. What do you think we're going to change then? If A is still less than B, what are we going to change with C? We're going to make C less than 0. So what kind of number is C now? It was positive up here. Okay, C was a positive number. Right here, what kind of number do you think C is going to be? Yeah, it's going to be a negative number. All right, then, now watch this very carefully. If I took A and B, now let's put some let's put a C in there. If I multiplied by C this time and multiplied this side by C, remember what kind of number C is. C is a negative number, okay, because C's got to be less than 0. So if I take two things, the A and the B, and originally A was less than B, but if I multiply by a negative number, look what happens to my inequality. My inequality is not going to be a less than, it switches to a greater than. This is the part right here. This right here. Put stars, put bells, put whistles, put something on here, okay? Decorate this so that you know that this is super important. So if you have a number, A is less than B, or let's right here. If A is less than B, and I multiply by a negative, it's going to switch the sign. It was negative, or was less than, and what did it switch to when I multiplied by a negative? It switched to a positive. Just for the fun of it, let's put some numbers in on this one. Okay, this is the only one I'm going to do that to. So if A is less than B, so let's make it easy. Let's 2 is less than 5. All right, so we know that's true. Actually, yeah, we know that's true. But what am I going to do here? I'm going to take that 2 and that 5, and I'm going to multiply it by a what? A negative, right? Because C is less than 0. A number that's less than 0 is negative, so I'm going to multiply this by a negative number. Let's just make it -3. Multiply that by -3. Multiply that by -3. I thought I'd change the colors. I guess I didn't. It's no big deal. I'm not even going to put my sign right here. Let's figure out what this is going to be. 2 times -3 is -6. 5 times -3 is -15. Now, let's compare -6 to -15. What is true about -6 compared to -15? -6 is bigger. It's greater than -15. So look what I did. I took something that was less than, I multiplied it by a negative, and look what it did to the sign. It went from a negative sign, I'm sorry, I keep saying that. It went from a less than sign to a greater than sign. All right, so when you multiply or divide, okay, remember at the beginning I talked about that. It works for division as well. If I multiply or divide, not just by any number, but by a negative number, a number that's less than 0, that's a negative number, okay? Right here, C is a negative number. If I multiply both sides by a negative number, or if I divide both sides by a negative number, what's it going to do to my sign, my inequality? It's going to change the inequality. That's really the only time that happens. Every other time, the inequalities, the signs, stay the same. okay, that only changes. Look, it changed from here, went negative, to here. I keep saying that. Why do I keep saying that? It's harder than you think just talking to yourself on this. It's a lot easier when I'm talking to a group of people. But this is less than. It changed from a less than to a greater than. Because why? Why did it do that? Because I multiplied by a negative number. That's when that occurs. All right. I think I've repeated myself a lot on that one. The next two are pretty straightforward. Instead of if A is less than B, we're going to go if A is greater than B. And the same thing will hold true, all right, as what we did before. And if C is positive, remember this is positive right here, then I'm not going to change the colors. I'm just going to write it out. Then AC is still going to be greater than BC. As long as C is positive, if I multiply both sides by a positive number, the inequality does not change. This is greater than, this still is greater than. Okay, the only time that that doesn't work is in these situations right here. And if what? Not positive, not greater than 0, if C is less than 0. Again, C being less than 0 means that this is a negative number. All right. Now, if I multiplied A times C and B times C, what do you think is going to happen to the sign? I multiplied by a negative. So that means I'm going to change the direction of my inequality. It's this one. It was greater than, so what's it going to change to? It's going to change less than. Again, I'll put a little star, put a little bell, put a little whistle, do something, okay, to make sure that you understand that this is the one that's different. This is the one that changes. It's actually pretty simple once you get the hang of this, all right? Let me show you one more thing, and then we'll do a couple examples, and we'll quit. All right, the next one is called, let's change colors just so, we'll change, that's too close to that. Let's change it to yellow. All right, this is called the reciprocal. I actually used that word already today, didn't I? It's called the reciprocal property. And there's a couple problems on your homework that you're going to need to know this. So that's why I'm making sure I do this. For inequalities. Okay? So this is called the reciprocal property. Remember what the reciprocal is. The reciprocal is if you have a fraction or even just a regular number and you flip it. So for instance, 3/4. What is the reciprocal? It's not equal, okay? But what's the reciprocal of 3/4? Well, it's 4/3. What if I take a number like just 5? What's the I'll put an R here for reciprocal. Okay, what is the reciprocal of 5? Well, you know that 5 is 5/1. How do I take the reciprocal? I just flip it. So I make it 1/5. Those are reciprocals. It doesn't mean they're equal to each other. It just means that that's what a reciprocal is. You just flip it, okay? Well, this step right here, this property, I should say, not a step, but this property says this. If A is greater than 0, all right, which means A is a positive number, then if I take the reciprocal of A, which is 1 over it, that's what we did here, right? If I took a 5, what's the reciprocal of 5? I put 1/5. So if A is positive, then 1/A is also positive. That's basically what that says. Okay, so if A is a positive number, then 1/A is also a positive number, is basically what it's saying. Okay, you could also do the reverse of it. You could say that if 1/A is a positive number, what do you think? It's just the reverse of this. So if 1/A is greater than 0 or positive, what do you think is true about A? Then A must be greater than 0. It must be positive. All right? It seems kind of weird. It's like, how in the world am I going to use that stuff? But you will here in a second. Not on the examples. They don't even have this on the examples, but they do have something like this. Let me see. Yeah, I think they have it on the homework. Or maybe it's the next section. Maybe it's the next section where they have something like this on here. But we're doing this now. Let's do another one. And we'll be finished this little part. So I'll change colors just so it... it's basically the same thing as this, except a is less than 0. So if a is less than 0, so if a is a negative number, what happens if I take the reciprocal of a? It's still going to be negative. Taking the reciprocal does not change the sign. That's basically what this says. They could have made this easy for us and just said, hey, look, if I take the reciprocal of a number, it's not going to change the sign. That's all they had to say. But they got to be all fancy and do it like this. And if 1 over a is less than 0 or negative, then what must be true about a? Then a must be less than 0. Okay, that's basically all that is saying. So they're just saying if the reciprocal of a positive number is going to be positive. That's what this says. This says the reciprocal of a negative number is going to be negative. That's it. So look, I didn't change the sign, did I? Taking the reciprocal, I didn't change the sign. What if I had this? What if I had negative 2/3? And I said, what is the reciprocal of negative 2/3? Well, it's going to be negative 3/2. You don't change the sign. Reciprocal doesn't mess with the sign. It just changes the top and bottom. Okay, you just flip them, and then it's still negative. That's all that's saying. Not that big of a deal. Oopsie daisy. Oops, let's get this back to where I want it. Let's put this up here. All right, now let's do a couple examples. That's what everybody's been waiting for. You want to know how to do the homework problems, right? So this is example 7 in the book. And it says to solve. All right, so here we go. 3 minus 2x is less than 5. Well, this looks very familiar to what I've done before. This looks, very similar to an equality with an equal sign here. So you basically solve for it just as if this was an equal sign. Pretend this was an equal sign with one exception. Okay, the exception, it's kind of two exceptions. The exception is if I multiply or divide by a negative number, I'm going to have to change the direction of this inequality. That's the only time. If you add or subtract, or you multiply or divide by a positive number, this inequality stays exactly where it is. It stays less than. But when you multiply or divide by a negative number, that's when this thing changes. All right, so let's do some work here. So minus 3, that adds up to 0. Bring down a negative 2x. Do we change the sign? No, we don't change the sign because all we did was subtract. You can add or subtract and it doesn't change the inequality. And this is a 2. Now, look what we're doing here. Now, I'm going to I want x by itself, so I divide by a negative 2 on this side, divide by a negative 2 on this side. This is what it's all about. This whole entire lesson basically boils down to what we're doing right here, all right? It's when you divide or sometimes multiply by a negative number. If you multiply or divide by a negative number, you have to change the sign of the inequality. If I would have multiplied or divided by a positive number, you would not change the sign of the inequality. You only change the sign when you multiply or divide by a negative number. Are we multiplying or dividing by a negative number here? Absolutely. We're dividing by a negative 2. So let's figure out what this is. That's just going to be an x. This is going to be a negative 1. What's our sign going to be? It's not going to be less than. It's going to be greater than, because we had a property up there with the multiplication that said if you divide by a negative number or multiply by a negative number, you have to change the sign of the inequality. And that's it. Now, to tell you the truth, I circled that. That's not really what you're going to see as your answer. Here's how you're going to see the answer. Remember we talked about that interval notation yesterday? So we could do it a couple ways. I would be okay if you kept it like this, to tell you the truth. If you wrote your answer like that and you circled it, I'd be fine with it, all right? So I'm cool with this. But when you flip to the back of the book, you might see a couple other things that look kind of weird. So the first way they're going to look at it is this. They're going to write it in set notation. When you get into higher math, these mathematicians love the sets and they love putting stuff in sets. So that's what they do here. Now, they put x, but they're not just going to say x is greater than negative 1. They do this. I first saw this when I went to college, okay? And they did this all the time afterwards. So they put x such that, that little straight up and down line right there just means such that. So it's the set of all numbers of x such that, and that's, if you were going to read it, that's how you would read it. x is greater than -1, and then close the set like this, put the brackets there. This right there is kind of a more formal way of writing the answer. This is a little more informal. This is kind of a nice formal way. This is what mathematicians like to do. I don't know why, to tell you the truth, but you see it all the time, so you just have to get used to it. You'll probably see this. I didn't look in the back of the book, but if you look in the back of the book, my guess is they'll probably have the answer like this. Or another way you could write it is in that notation that we talked about yesterday, that inequality notation, and it would look like this. Now, x is greater than -1, so how would I graph that? So x is -1, x is greater than -1. It's not a bracket, it's a parentheses, and then it keeps on going forever. And where is forever? It's at infinity. All right, so that's how I would graph it. That's supposed to be a -1, looks kind of ugly. But how would I write this in this notation? I would write -1, comma, infinity, and put a parentheses here and a parentheses here. So I don't have my book in front of me, to tell you the truth. I'm just going by my notes. But I have a feeling in the back of the book, they may write the answer like this, okay? Or they might have both of them, okay? You just have to check. You guys can talk amongst yourselves on how you want to write it. I would be fine with this, okay? So Mr. Hammy is fine with this, okay? So if you just circle that, you're cool, you got it. If you want to be a little more formal, like the book does, you can write it like that. At least be able to look in the back of the book and say, oh yeah, that's the same thing as that. Okay? Or you could write it like this. I would accept any of these three, to tell you the truth. But I have a feeling the book gives you this or both of them. I'm not really sure. So you're going to have to look that up. All right, let's do one more example and we'll quit. I've talked too much already. I'm sure you agree. So example 8. And we're going to solve. And here we go. Again, it's going to be an inequality, kind of the same thing as we just finished doing. And 2x minus 3. All right. Color, let's use that one. Well, let's see what we can do. We got x's on both sides now. I'm going to subtract a 2x. I don't have to teach you how to do this stuff. We did a whole review chapter on this. All right, so I subtracted 2x. I tell you what, in the same step, why don't we just get rid of the 7? So subtract a 7 from both sides. Let's bring everything down. What do we get? We get a 2x. That's 0. That cancels out. Did we divide or multiply by a negative number? No, we didn't. So I can keep my inequality exactly the same. That cancels out, and that's a -10. One more step and we're finished, basically. So I divide by 2, divide by 2. Now, I did divide by a number. Does that mean I changed the inequality? No, it doesn't. If I divide by a positive number, it doesn't change it. Only if I divide by a negative number or multiply by a negative number. I didn't do that. I divided by a positive number, so this still stays the same. So this becomes an x. This is greater than or equal. Let's do some simplification. -10 over 2 is -5, and that is your answer. Again, you could write it like that, or you could write it in that fancy set notation. So we put that little bracket for the set. We put x such that x is greater than or equal to -5, and then close the bracket. All right? Seems a little extra for me, but that would be fine. So I'll put an or right there. You could write it like this, or you could write it in that set interval notation, or whatever we called that thing yesterday. Notice it's greater than or equal to, and it's greater than, so the -5 is going to be first. The infinity is going to go there, but what kind of symbol do we put here? We put a bracket. Why do we put a bracket? Because it's greater than or equal to. Infinity always has a parentheses, so we could write it any of these ways. All right, you don't have to have all three, just have one of them. Tell you the truth, if it was me, I would just write it like that, okay? But if you look in the back of the book, you'll probably see it like that. All right, I hope that helps. And let's put your homework down. So your homework, and hopefully, I don't know how long this took, but hopefully you have a little bit of time in class to work on this. We'll see. So it's section 1.5, part 2, and it's page 133, and it is 53 to 67, and again, you're just doing the odds. All right, so sorry I'm not there today, and I won't be there tomorrow either. I will be back on Monday, hopefully. So I am not sick, by the way. My daughter tested positive, and so I have to stay home, and so that's why I'm home. So I'm feeling fine, but precautions make you stay home. So anyway, that's why I'm home. What was I going to say? Oh, homeworks. So I am not going to collect homeworks until I'm there on Monday. All right. So I'm trying to think. I think I'll have enough time. Well, let's see. You guys aren't going to be there on Monday. So this will all be due when you get back from the midterm break. Okay. So I said today or yesterday in class, it's actually today, but yesterday in class, I said that I would give you 2 more homework assignments to help bring your grade up a little bit. But unfortunately, I can't do that because I can't be there to collect it. So we're pretty much done the second marking period. So whatever you've turned in so far for the second marking period, that's it. That's your grade. All right. I'm not going to include anything else. So this will be yesterday's assignment, 1.5 part 1, and then today's and tomorrow's 1.5 part 2 and 3 will all be part of the third marking period. Okay, just because I'm not there. Sorry about that. All right, well, enough of that. I hope this helped, and maybe I'll see you tomorrow. I think there's supposed to be some weather on Friday, but if not, if you're in school, I'll have one of these for you to watch on Friday. All right, we'll see you. Bye.